Okay, so today is kind of putting it all together and just giving us a chance to look at those examples that we've been talking about in class where you can't take the derivative of the inverse. And so you're forced to actually do the derivative of the function that's given to you and then look at the relationship of what that slope is for the inverse. And of course, we have been talking about this. And so the slope of the inverse function at a point, AB, equals the reciprocal slope of the actual function at the point, not AB, but BA. Because remember the inverse, right? And you switch the point around. Or rather, we could look at it in the reverse way, or the converse, that the reciprocal slope of the actual function at the point BA would be the same thing as the reciprocal slope of the inverse function at AB. So let's look at how that's applied here. See, we have the function f of x equals cosine of x, and we want to find the slope of the inverse function at this point. So what needs to be going on in your mind, first of all, is I could find the inverse function, and of course that would mean that we'd have the inverse cosine. And we don't know the inverse cosine's derivative. We don't know that. So what we're going to be forced to do is to find the derivative of cosine of x. And of course, the derivative of cosine is negative sine, right? But instead of finding it at the point 1/2 pi over 3, because that's the point that goes with the inverse, what we're going to do is we're going to find it at pi over 3, comma 1/2. So to do this, that's pretty simple, honestly, is you're going to basically say, okay, that means negative sine of pi over 3. And so that is negative root 3 over 2. And so my answer then is going to be negative 2 over root 3 because we want the derivative of the inverse, or the slope of the inverse. And so we just simply do the reciprocal of that. All right, let's see if this next one makes more sense. All right, we have this inverse function is sine squared of x. I want to know f prime of 3/4. And so, sorry, that should say prime. And so where we're going between 0 and pi over 2, or the first quadrant. So in my mind, what I need to be thinking of, what this is telling me is I need the slope of f of x at the point 3/4, comma something. And of course, that would be the same as the reciprocal slope of the inverse function, right, at something, comma 3/4. So this is where it gets a little tricky. See, they're only giving me one piece of information. They're giving me the x value for the actual function, but what we only have is the inverse function. So the first thing that you need to think about is, all right, that means that what I can do is I can take sine squared of x, and that means that the y value is equal to 3/4. So I basically am saying the function equals 3/4, and I want to know what x value is that happening at. So I'm going to take the square root, and I would have the sine of x equals the square root of 3 over 2. And again, remember that's plus or minus, right? So when does sine equal root 3 over 2? And so we would think, when does sine equal root 3 over 2? And of course, that's pi over 3. Now, why am I not listing all of those angles that this occurs with? My hope is that you caught this part that basically indicated that it was in the first quadrant. So we still haven't answered it because we still have to find the slope. We still have to find the slope of when, right, this function is at 3/4, comma something. So what I'm going to do is I'm going to do the derivative now of the inverse. Okay, so that's phase 1 to figure out the x value because that's what I needed. And so I'm now going to do the derivative of the inverse, and so as to not be too confusing here, that's what I want to do. And so I'm going to do the derivative, so that would be 2 sine x cosine x. And now we have this x value, and I'm going to plug that in for that x. So I have 2 sine of pi over 3 cosine of pi over 3. And so the sine of pi over 3 is root 3 over 2. And the cosine of pi over 3 is 1/2. And just to simplify things a little bit, that means that those 2's would basically end up dividing out, and I'd be left with root 3 over 2. Again, though, this is of the inverse. I want the actual function, so now all I need to do is I need to flip that right around and realize that that is the slope that they were looking for. All right, let's look at another one. Find, here we go, f of x equals e to the 2x. Find the derivative of the inverse of e to the 6th. Again, and you'll find that I typically will write this out. So what does this mean? This means to me that I want the slope of the inverse function at a point e to the 6th comma something. But what I know is the actual function. So I know that that must mean that it's the same as f of x, the same slope, same as, oops, sorry, let me just write that, reciprocal slope of f of x at something, comma, e to the 6th. So before I go too far, I'm going to use this function to determine when does that equal e to the 6th. I'm hoping that's a pretty easy fix for you, and you can see that, oh, this isn't just question mark, this is 3. And so that means that this is e to the 6th, 3. All right, so now what I'm going to do is I'm going to find the derivative of f prime of x, which of course is e to the 2x times 2, and I'm going to plug in 3 at that spot, so that becomes 2 e to the 6th. Again, though, I want it of the inverse, and so all that I've got to do is flip that puppy right around, and so that is the slope that I'm looking for. And hopefully that gives you 3 good examples that you can utilize as you're working through these. But this little step that I take of writing it out, what does that information mean to me with the slope of the inverse at such a point, same as the reciprocal slope, that helps clarify things, and I just hope that you take the time to do that so that you can get those questions right. It's not only important that you do them quickly, but to do it accurately.